I had to replace one of the motors on my quadcopter the other day. I had the motor off, I was just kind of playing with it. And I realized that these bell housings just make surprisingly good tops. And they're a lot of fun to play with. So I immediately got to thinking about how I could make these things easier to spin, make them spin better with like some sort of 3D printed handle. And then I realized that I was just missing the most obvious answer the whole time. These are motors. They're meant to spin quickly. If I could just find some way to pop the housing off while it was going full tilt, then I could have a pretty neat spinning top kind of thing. Here's the first sort of prototype that I built up for testing getting the top to spin with a motor. So here I just have a speed controller, which I'm hooking up to my power supply now. And then on this little breadboard, I just have a simple 555 timer circuit that I designed that will give off the same frequency PWM signal as the RC receiver. So depending on whether or not you're pressing that button, it'll give either full throttle or no throttle to get the top spinning. And then over here I just have the motor mounted. I just wanted to put it somewhere I could clip it in place because right now getting it to spin, or launching it I guess, is more of a two-handed kind of process. So I'll just show, come on, there we go. So I'll just show how I've been doing this for now and how I plan on doing it in the future as well, I guess. So I'll just start this up, give the power supply some power. Turn on the power supply first. There we go. So we can hear the ESC initialize, and then once I let go of this button, the motor will start spinning, so it'll get a bit loud. I don't know if you'll be able to hear anything after that, but basically I'm just going to push the motor out of its housing with this Allen wrench. Focus. Come on. Anyway, I've marked off the depth on it, just so I know how far to push it out, and then that'll drop out the motor. So let's give that a shot. So we get some pretty good speed out of that thing. Theoretically, these are, well, I guess not theoretically, but these are 2300 kV motors, I think it says on here. So, come on, focus. They're 2300 kV motors, and I'm giving them 12 volts, so they should be hitting somewhere close to 27,000, 28,000 RPM unloaded. Of course, that's a theoretical max. There'll also be all sorts of other things factoring in, and I'm guessing that once I get these going, maybe add a little bit of weight to them to get them spinning better. They'll probably be doing about 20,000 RPM, which for a for a tabletop isn't bad. So I'll play around with this idea a bit more and see what I end up coming up with. Here's the design that I came up with for the launching mechanism for the tops. This is the first prototype, and it barely functions, but it functions enough for me to be able to learn what I could from it and work on a better one. So basically, the head of the motor, the bell, is pushed out by this Allen wrench that's in here, and it's forced down with some rubber bands. So if I pull this up, and then this little lever in here locks it in place. So if I add the top back in, and then by releasing this lever, quite forcibly shoots out the end of the motor. So I might need to do some adjustments with the rubber bands to figure out the best force for that. But for now, it seems to be working well enough. back here is the momentary switch. So because of the way that the circuit works, the switch needs to be pressed for low throttle and released for full speed. So the spring in here forces this button down, and then on the first press of the button we sort of disengage the switch, which gets everything spinning, and then on a further press we release the top itself. So there's supposed to be a spring in here as well, but I spaced these a little bit incorrectly, so I'll need to adjust that, otherwise the spring doesn't fit. And when the spring is in there, there's enough force behind this button to release it, and this spring here also doesn't have enough force to re-engage the button when it's let go, so I figure I just need to move this down a little bit further. Longer lever arm should give it more force. So I guess I should probably try this thing out now. I haven't actually given it a test try yet, so I'll get that all hooked up and then we'll see how that goes. So I've got everything pretty crudely hooked up right now, just to give it a first test shot. So see if I can hold this while still using it. I don't know how difficult it'll be to operate, but turn on the power supply now. Sounds like the speed controller's going, that's good. So let's see if we can get it to spin now. So it's twitching, and that's actually the problem with this motor. It had loose wires, which is why I'm not flying with it anymore. So hopefully I can get this spinning again. Come on. There we go. And well, it's on the floor, but it's spinning very quickly, so I guess it works for now. So I wanted to try removing one of these rubber band strands, so there's a little bit less force pushing out the top, so hopefully I can get a more stable launch without it just flying everywhere all of a sudden. So this is again with the prop adapter on it. Let's see how this fires. There we go, so that wasn't bad. I suspect it'd spin a lot longer if it wasn't up against these cords, because the prop adapter does have these holes in it, and when the edges of those holes, the edges of the cords, I'm sure it's taking away a lot of energy. But hopefully tomorrow I'll get a chance to try it out in some sort of big metal bowl to see if it'll spin better in the center. It's just pretty late at night right now, and launching that would make a lot of noise in the metal bowl, so I don't want to wake any neighbors up or anything. So I guess I'll look further into fixing up some of the design issues on that launcher, and maybe see about making bodies for these things, see what they can really do. Alright, so I just finished printing off version 2 of the launcher, and I guess I'll just go over how it's different from version 1, and I guess sort of how everything goes together, because I didn't really cover that with the last one. So the first change I made is just extending the base plate out. I had to do this because I made this trigger section longer, so that way it could have a little bit more force to hopefully push this once it has the spring in it, and also give the spring more force since it's further back here to push against the button, which goes in this spot. So I've also beefed up the button carrier because it actually snapped off on the last one and I had to use hot glue. And I also brought this spring retention area for the main mechanism further back, so that way the spring will hopefully fit better and maybe have a little bit less holding force. So the way that spring mechanism works for this, this is the piece. Come on. There we go. So this is the piece that actually does all the work. There's this little slanted edge on it. I don't know how well we can see that. There we go. It's just at an angle, and that basically fits into this groove down here. I guess I'll show it. So it slides in there. And then when that's in place, the pin that'll be launching the top can't move. But once it's moved out of the way, then that's able to push through to the bottom and launch the thing out. So I guess I'll just start assembling this and see if I run into any problems while doing that. So I found that it's just easier to fit this arm before putting in the lever, or the trigger, I guess I think I called it, because you can insert it while it's open and then sort of start to close. The mechanism. There we go. So now everything's in place here. Fairly tightened down. Let's see if I can get this on camera. Yeah, so there's the hole that the pin goes through, and once this closes, it just blocks off that hole. So it's pretty simple, and because the pin is resting right against it, there's just the force of the rubber bands pushing it down. It doesn't have the total force as it's moving, the momentum behind it, like it does when it's launching out the top. So that's why that piece is able to be so thin and not just get punctured. So actually, let's see now if the spring fits in this version. Whew, tight fit, but look at that. So once again, here's close up so we can see that hole. And now it automatically attempts to close itself. So that's part of the reason that I had the slanted design on that blocking peg in there, because I wanted it, the original intention was so that when you put on another top, it would push upwards on the pin, and hopefully it would push it up enough where that would be able to then slide underneath it and lock it in place, so you wouldn't have to cock it up every time you tried to reload it. After seeing how the test on the last one worked, I've mostly just scrapped that idea, because for that to work properly, this plate would have to be super thin. There we go. So that's a little bit firmer action, and then we can still move this part enough to be able to launch it. Let's see if we can get that again. Come on. I also added a little bump on this trigger mechanism so that it gives a little bit more pressure against the button in here, because I was having trouble with this one getting it to keep pressing down on the button. See if you can hear, there's a click when it presses. So normally when you let go, it doesn't click in place, and then now the button's actually pressed. So hopefully between the more forceful spring on this one and that little bump in there, it should be able to provide enough force to actively press the button when it's let go. I can definitely see it moving, so I guess I'll grab the multimeter and just check continuity across there. Cool, so it looks like it is providing enough force to squeeze the button closed, so that's perfect. So I also redesigned the launching mechanism a little bit. Before I'd just been using the Allen wrench. That would explain it. With rubber bands to pull it down. But what I decided I'm going to do is I'm going to end up cutting off this curved bit at the end of the Allen wrench and instead fitting this piece that I designed onto the top of it. So it just has a hole for the Allen wrench to go through, and then this little groove to hold the rubber bands in place, because that was one of the problems I'd been having with the last one, was that the rubber bands kept slipping forward. So it was either pulling the Allen wrench at an angle or they just kept coming loose and I wasn't getting enough force. There we go, there's our bit. I'll cut down to size. I'll fit this now into here. Just a basic fit, and then I'll get it all squished together in the vise over here. There we go. So that's a pretty good fit. I guess it's time to rig this thing up now and see if it works. There we go. Let's cock it back. Cool, so it looks like it's locked in place. And let's give it a test squeeze. Perfect. I'll attach the motor now. Let's get this thing loaded up. There we go. So I guess I'll just test first to make sure it'll eject the bell housing properly. Yep, properly and quite forcibly. So I might again have to cut back on the rubber bands a little bit when doing this. Let's pop off one of these. You know, let's try two and see if we can launch with just these two strands on it. Definitely easier to pull back. Let's give it a shot. Nope. So only partially ejected, so it looks like we need at least 3 strands. There we go. Yeah, that's pretty good. So far, so good. Let's see now if we can get it spinning. So the reason it's been stuttering like that is the reason I retired this motor. These wires one of these wires is a bit loose, so it's not getting everything to spin properly. And once I get this finalized, I'll have a way to hold the wires in the proper place. But until then, cool. So a soft touch gets everything spinning, and then a fuller touch will release it. Cool. I guess my next step now is, this circuit board. I want to make it, I have some perforated board so I can actually solder everything in place. I'm just waiting on some proper value resistors, and that should be shipping in from Amazon tomorrow, because these are just bodged right now. I need 2K here, or technically 2.5, and I just have two 1K in series, and then these ones were just random guys that I found lying around that were close enough to the values I needed. So once all of the resistors come in tomorrow, I should be able to get this soldered up. Well, I remembered something I wanted to try yesterday. I think that's pretty self-explanatory. So let's give it a shot. I'll try both the motors without the tips on them and the ones with the prop adapters on them. The regular ones spin fine in the center, but I think that once they reach the edges, they're going to hit, and that'll be a bit of a problem. And then these ones should be able to easily travel up the edges a little better, but it's very tough to get these ones to spin by hand because of how tall they are and how slippery the surface is. So I will hook up the launcher again, and we'll see what we can get in here. Well, that did not work as I expected. It's still spinning though. It's just across my room on the floor. I'll give that another shot. Hopefully it'll stay in the bowl this time. I'm also going to put on safety goggles because it shot around pretty viciously in there, and I like my eyes not to be punctured by things, so... Nope. Same problem, once again. There's this weird burning smell that comes, for some reason, when it hits the bowl. Not sure what that smell could be from. Doesn't look like anything on the top's being damaged, but it smells kind of like... I don't know, like ozone a little bit, kind of like burning electronics, but it's nothing on this circuit board. I've already checked that over. So... I guess I'll load up the one with the adapter now and we'll see how that goes. So that burning smell seems to come when the edges of these tops hit the edges of the bowl. So I wonder if it's burning off some of the paint or something. That's on the edge of these things, or if it's burning off some sort of coating on the bowl from all the friction, but hopefully it's not ruining this bowl. I tend to use that for cooking sometimes, but whatever. Alright, so here's the test firing of the one with the adapter on it. Well, looks like that had very similar issues. Shot around a lot, stayed in the bowl for a bit longer, and luckily ended up on my desk and not halfway across the room like last time. So I guess I'll give this another shot. So it seems to really like catching up. I'm guessing it's catching up on these holes once again, just because there's slight inconsistency. Come on, focus. Slight inconsistency in the surface. You can actually see there they're not quite as rounded as the rest of it, so if they're rubbing up against an edge, they'll definitely catch on it. What I can do though is try removing that, try spinning it on this surface. Doesn't look like that helped too much. It's mostly when these edges catch. So I think that the next thing I'll be doing is designing something to fit over these with more of a smoother edge on it. Get rid of these, and I guess probably some weight distribution further out to give it a bit more spinning force. Alright, so I just removed it so that there's only 2 layers of rubber band on here now. I'm going to see, this didn't work before, but I'm wondering if when the top is spinning, if somehow it has, if somehow it will get released a little bit easier from it. So let's give this a shot. Well, that certainly wasn't what I was expecting to happen, but it was pretty cool, so I'll give that another shot. Actually, before I try that, I'm just going to try it again with only the 2 rubber bands without the nut on the end, and we'll see how that turns out. There you go. Alright, so unfortunately I couldn't find the plastic bowl I was looking for. It was basically like the other one, same size and everything, just made out of plastic. But I do have this plate, and I think that the curve on the edge is shallow enough that it won't cause any crazy things to happen with the top, but also steep enough that it won't just slide on out. That was pretty fun. I'll try it again with the one without the prop adapter on it, but I suspect that because it's so low, the edge is going to whack against here, and it'll just shoot across the room like all the rest of them have done. Yep. Yeah, so that one as expected. I guess I'll start working on some designs to give a little bit of momentum in these suckers and see how long they can really spin for. I printed out a basic top design that I made for this thing. So I fitted it onto the motor, and unfortunately I can't get it back out right now, so I'll have to figure something out about that. But after I printed it, though, I accidentally crashed the build head into the top of it, so it ruined the nice smooth finish that it had. And I started sanding it down, and then I realized that I had a better option potentially. So I think that if I fit it into the launcher, then I can spin it and use it kind of like a lathe with some sandpaper to get a nice smooth finish on the surface, and hopefully that'll help it spin better. There we go. It's smooth enough for me. So I'll get this thing on the launcher now, and we'll see if it spins any better. Well, well, I tried. Well, it doesn't spin as well as the other ones, but I suspect that's something to do with the edge of it catching the plate. So I'm going to try on the back of the plate where there's not really still a slight lip. So hopefully it'll stay in place, but I don't think it'll be as much as the other side in terms of taking away from its spinning performance. Well, that wasn't too bad. I think what I'll do with the next design is make it so that it can be put on the motor, and then the prop nut will screw down and hold it in place. That way it'll still be spinning on the nice smooth metal tip without any worry of any 3D printed crap screwing up the rotation or bumping into stuff or any uneven edges, but it'll still provide the extra balance and weight of the printed part. So I guess I'll try that out. Alright, so today is now tomorrow, and got my resistors and some PCBs in the mail, so I'm going to start putting together the circuit board. But first I think I'm going to do a test just with the exact value resistors to make sure everything still works normally before I get everything soldered together, and then hopefully I'll have a much more compact board that I don't have to fiddle around with as much when trying to launch this thing. Alright, so I've got all the proper value resistors swapped in. Let's fire it up and see if it still works. So already I can tell it's not working. It's just going at full throttle the whole time. Alright, there we go. So it looks like I just need to recalibrate the throttle range on the ESC for the new value resistors, and it even sounds like it's spinning a little bit faster than before, so that would be cool. Yeah, it still works, and it definitely seems like it's spinning a little bit faster, so hopefully we can get some cool results out of this. I'm just going to solder everything now. I probably won't record that though, because that'll be pretty boring. Maybe a time lapse or something. So here's the finished board. Tried to make it as compact as I could. I think I could have squeezed things a little bit tighter, but really this isn't that bad, and I'll cut off the extra once I test this out. If I was smart, I would have built everything down this end, so I could have used these mounting holes, but I didn't think that far ahead, so this is what I got. I'll hook it up now, and we'll see how it works, or if it works, I guess, is the real thing. Alright, all hooked up. Contact. Accidentally went into programming mode there because I didn't have the button held down. Oh, there we go. And a whole lot of nothing. Somehow I had a feeling this would happen. I guess it's troubleshooting time. Alright, I think I fixed the problem. I just had one of the wires going to the wrong pin on the transistor, so let's just see how this goes now. Already sounds better. And that's a good sign. Well, I mean, if it were spinning it'd be a better sign, but that's the motor's fault, not the circuit. Probably shouldn't let that be banging around on the speed controller, but looks like that's all set. So I guess I'll cut away the rest of this board and then figure out some sort of housing for this thing. By housing I mean probably just a way to strap it to the launcher for now until I figure out something better. That's a much better size. I'll just sand down actually these edges aren't that rough, but I'll sand them down anyway. And then strap this thing to this thing and see what happens. So unfortunately I don't have an oscilloscope, so I can't show you how this circuit works on my actual circuit, but I have it made up here in 123D Circuits, which is a great free online circuit building program by Autodesk. I use it a lot just to prototype things before I build them, so I don't blow up any of my components. So I'll just show you. So this circuit is basically just a 555 timer circuit with a little bit of extra stuff added on. So a 555 timer generates a PWM waveform, which if I start this up, you can see on this oscilloscope here. So this one has a 90% duty cycle and a 20 millisecond length, I guess, or a form length. I'm completely blanking on the word for it now, but basically it operates at 50 hertz, and this is the same frequency as the RC receiver. So the way that this works, there are two resistors and a capacitor that control the frequency of the waveform. I won't get into that too much because honestly I'm still learning this stuff right now, and I'm sure there are better places to learn it, but I basically looked up 555 timer calculator online, and it gave me a website where I just put in the type of waveform I wanted to generate, and it gave me the value of the components that I needed, the resistors and the capacitor, to get the right waveform. So that was super simple. And then I have, if you'll notice, there are actually two resistors down here, or three. So there's the main one for the timer, which basically sets the time base, so our 20 milliseconds. And then there's another one which sets the pulse length. It's not that simple, but I'm simplifying things dramatically right now. So when I press this button, we'll see that the waveform changes. And what that's doing is it's basically switching in this other resistor in parallel with the first one. I think if I go to component view, there might be a, oh, that's a mess. Let's get that out of here. There might be a better view of this. So basically, this resistor, with value of 250 ohms, which I think I have 240 in there just because that's the closest, nearest value, is constantly in circuit. And what that does is it gives us our waveform with a 90% duty cycle over 20 milliseconds. And then when I press it, our resistance across here will drop, because once you add another resistor in parallel, depending on the value, it drops the total resistance. So I think I can actually demonstrate that in here really quickly if I just throw in a multimeter and I put it on negative there, positive here, start, resistance. All right, so we can see 300 ohms, and then when I press this button, that drops down closer to 130. I think 150-ish is about what I wanted, but just with nearest value resistors, this is what I'm getting. And also probably some sort of mess up in there. So anyway, this waveform is ultimately not what we want. We want the inverse of this, because PWM on the receiver is a 20 millisecond base, and then the signal, the little blip that we want that's positive, is 1 millisecond long for low throttle and 2 milliseconds long for high throttle. So right now we have one that is, with the button not pressed, we have 18 milliseconds high, and with it pressed we have 19. So we just want to invert that. So what I have down here is just this little PNP transistor. The way that this works is it's basically like, I'm going to simplify this a lot, so I suggest if you want to learn more about this, definitely look into it elsewhere. But it's basically a switch. Now a PNP transistor works based on negative voltage, so it's looking for a negative voltage to go into it to tell it to open up and allow the rest of the current to flow through. So the way that I have this hooked up, if we just look at it in this diagram, it'll be a little bit easier. Actually, if I reattach the wire, it'll be a lot easier. There we go. Now if we look at it in this view, so we have our output from our 555 timer, which is that waveform that we were looking at before on the virtual oscilloscope, going to the, what was that? The base of our transistor. And then over here, going to the emitter, we have just a standard 5-volt signal. So basically what the transistor is doing is it's comparing what's coming in from the base, or the emitter. Is that emitter, collector? Emitter, and it's comparing it to what is coming in the base. So we have to think about this in terms of voltage, and how voltage is the difference between two voltages, or two charges. Sorry, the wind's blowing and it's making my shades make weird noises. So voltage is basically the difference between two charges. So if we have 5 volts coming in here, and then this output was 5 volts most of the time, that was our positive, the higher end of the waveform that we were seeing. So when that's 5 volts, the effective voltage difference between these two charges is 0 volts, so our transistor is going to be closed. But once this drops down, so when we have that little dip in our waveform, like we did here when we were showing it, so when that little dip happens, then we have negative 5 volts across our transistor, because now this is 0 volts and we're still counting the 5 volts that are going into the emitter side here. So now we have negative 5 volts across the transistor, and that causes it to open up because it's looking for a negative difference, which allows current to flow out the collector. So the collector is what we have going into the ESC, and that's our final waveform. So if I move this oscilloscope probe over to the collector, and I reattach the base to the output, and now when I start it, we see that we have this little bump, which is what we're looking for. And when we press the button, it's half as short. So this is our low throttle, this is our full throttle. So that's just what that's doing. For the 555 circuit, like I said, you can just Google things, just Google any questions you have. All of this is completely self-taught to me. So, I mean, if I can do it, anyone can do it. You don't have to be in any special course or anything, or any class to figure this kind of stuff out. It's just a little bit of Googling and you can figure out what to do here. So, yeah, that's about it electronics wise. Like I said, I don't really have any idea what I'm doing with any of this. I just kind of learned this as I went. I'd love to eventually get this onto some sort of printed circuit board, but I have no material to make a printed circuit board, and I certainly have no knowledge of how to properly lay one out. I think this looks okay, but like I said, I have no idea what I'm doing. So I guess that's my next step, is to learn some sort of proper circuit design program and maybe get some boards printed if I decide I want to keep making these things. I touched the circuit board and speed controller with some masking tape for now, just to get them all in one place so I can get a feel for how this thing feels in the hand, now that I don't have to worry about stuff dangling off and everything. So I think I'm going to make it a tiny bit longer, and have some sort of mounting option, because I plan to have this use a battery pack from one of my quadcopters, so that way I don't have to be attached to the power supply anymore, and that'll just hang off the back, and I think that that'll provide a good handle for most of it. I just need some way to attach it. And then this could be a little bit wider, which will give a nice mounting spot for this board on the bottom, and I'll figure out something cool to do with the speed controller. I'm also probably going to more fully encase all of this, just so there isn't stuff flapping around, and I'll add some handles to here to make it easier to cock back. But let's just give this a couple shots now that I can actually hold in my hand and see how it does. It also seems that the motor seems to like this sort of wire position, so I'm not sure exactly where the break is in these wires, but as long as I loop them out like this, it should be fine. I'll probably use a different motor when I finish this thing up, just so that way I don't have to worry about wire position too much. But, here it is acting up again. I don't know what else I expected. It's on the floor. Now that I have the ability to quickly launch things, I'm going to try doing 2 tops quickly after each other, and we'll see what happens when they bang together. Hopefully they won't shoot across the room too far. I think I'm going to split this video into 2 parts. I originally didn't want to have to do this, but I have 3 days of footage already, and I just don't want to make a 2-hour long YouTube video or anything like that, so this will probably be the end of it for now. This is the end of prototype phase, and hopefully next video will just kind of be a showcase of the finished one, as well as a couple ideas that I have for some cool, I guess, Beyblade-like tops made out of these. I'm pretty excited for that.